Hello and welcome back to Electronics with Emrys. In this video, I'm going to be showing how to build a board in KiCad 6. Once you have the KiCad system open, we're going to click on New Project here. And then we're going to go to a folder, which I've already made, called Simple Board, and give it a name. Then we can go into the schematic and start adding components. You just have to double click on this and it immediately opens. On my computer, my second screen is going to open everything, so I'm going to have to drag it over to show you, but you should have it all show up where you can see it. In this main window, you can zoom in and out with your mouse scroll wheel. So the first thing I want to do is add a component to my board. So in order to do this, we're going to add a symbol, which is this icon off to the right. After a short time, the window opens, and then you can start looking for all your components. There's quite a few things already in here, so what I'm going to do is grab a simple logic device. So here I'm going to get the 74HC14. This is a 14-pin logic device, and it has all of these separate pieces. So you can see each one of these has different pin numbers, so these are the different inverters inside of the device, and then it's going to have a separate piece for the power. And I'm going to make a breakout board, so my goal is to have half the pins on the left and half the pins on the right. So this isn't ideal for me, but I'm going to go ahead and just place this because it'll work fine. So I'm going to rotate this with pressing R. So I'm going to have pin 1 at the top, and then pin 2 below that. Then I have 3 and 4, and 5 and 6. Now 7 is going to be ground. And then we have 8 and 9, 10, 11, and 12, 13, and 14 is going to be on our supply as well. So I'm just going to rotate this around and we should be set. Now I need the actual headers that I'm going to break this out to. So I have a 14-pin device, so I need a 1x7 header on each side. I'm just going to go back to the add a symbol. And then I can go in here and type in CONN. It took me a little while to figure this out, but once I understood it, it's actually pretty easy to find all of your different headers with the CONN prefix. So now I'm going to go a 1x07 male, and you can see that's exactly what I've got over here. What's interesting is there's no footprint directly associated with these parts. And we'll get to how to do that in a minute. So now I've got this one on this side, and then I'm going to want to copy that. So I'm just going to press Control-C with it selected, and then Control-V to paste it in. And I can right-click on this and mirror it horizontally to get the pins to face the opposite direction because I want to wire those up to my devices inside of here. And let's go ahead and zoom in a little bit so you can see it better. And now I press Escape to get out of the tool that I'm in and back to the standard selection tool. Whenever you highlight this over a pin, it'll change to the wire tool. You can also press W to get into the wire tool, but that immediately starts a wire. So I'm going to go ahead and just start from here, draw this up to pin 1. And I'm not going to worry about making this pretty, so my apologies for anyone with OCD that is going to be driven crazy by this, but I'm going to just get these wired up good enough for this simple tutorial. Now on the right hand side, I'm still going to leave pin number 1 at the top, but that's going to be my 14th pin of the device. So, and then we're going to have 13, oops, I put these the wrong way around, my mistake. And I'm going to go ahead and wire this. 13 goes to right here. 12, 11. So just to show what happens if I accidentally go over one of these wires. So like if I were to do this, then you see that it wires up and connects it. So you got to be careful in this. You can't have wires take up the same space like you can in some other editors. I like that because it makes it so you can't have something that's confusing. You can't tell if a wire is going one place or another. So let's put that there, and then this is going to go here. Great. So now I have officially wired up everything. I want to name all of my components. You can see that's U question mark A, B, C, D, E, F, and then all the way through to G. I'm going to double click on this one to open this dialog and call this J1. Over here, I'm going to double click and call it J2. Now to do these, I could double click and name every one of them. I like that when you double click, the question mark is already highlighted. What I'm going to do is show you the annotation tool. You just go to the top, go to Tools, come down to Annotate Schematic, and the default set of setup is going to work for me. You can change settings in here to change how it numbers things, and just press Annotate. You can see that everything has been annotated, and we hit Close. So now these are all U1A, U1B, so these are all one device, and J1 and J2 were left unchanged. So now, if I wanted to create my PCB from this, let's go ahead and try to update the PCB. So again, under Tools, we go to Update PCB from Schematic, and you will see that there are some errors. Oh, sorry, went to my other screen again. It came up with the error, cannot add J1, no footprint, J2, no footprint, U1, no footprint. So I didn't put footprints on anything, but it gave me that nice error to let me know what's going on. So this is the screen that came up behind that. It's just a blank board. So let's go ahead and close that out, and I'll show you how to add footprints. There's two easy ways to do it. So first you need to right click on a component, and I found that some places, whenever you click on a component, it's not always selecting the component. So make sure when you right click, you get this full menu. And then we're going to go to Edit Footprint, or you can press F. The footprint is going to be in this library here. And this is a normal 1x7 header with 0.1 inch pitch, or 100 mil pitch, or 2.54 millimeter pitch. So let's go look and see what's available in here. Under connector pin header, and we have 2.54 millimeter. My headers are 1x7, and I have a 2.54 millimeter vertical. So this looks like what I want. Insert footprint in board, and then hit OK here. Or you can do the same thing for the other one. We're going to go to Edit Footprint, select it, and then this time, whenever that comes up, it's already on the same thing, which is kind of nice. It stays where you were if you want to have multiple devices with the same footprint. But you can also just double click on this, and that gives that footprint back. We hit OK, and we're done with that. Now, for this device, we'll use a different approach. If you just double click on any of the symbols, that'll bring up this menu. And you can then select footprint and click the same symbol here. And that brings up the same menu here. And I'm going to put on a TSSOP package. So let's go look under Packages. Here we can see Packages, or you can also filter to only Packages. And then under Package _ SO is where they put the TSSOP packages. So yeah, definitely, it took me a little bit to get used to how things are organized in here. I've found Google to be a good resource, so if you just don't know where to find something in KiCad, there's a lot of people who are using it, and there's a lot of available help out there that you can find. So I'm going to go down to TSSOP for this is the PW package, or the TSSOP package. It's a 14-pin package. This one has, you can see, a center thermal pad. Most packages won't have that for logic, so I'm going to use the one that does not have that center thermal pad. And then just double click on this, hit OK. And now I have selected the footprints for all of my components here. I'm not going to go into spice modeling here today, but I do want to show just briefly, if you double click on this, at the bottom you can select a spice model. So you can put a spice model in, and you can use this as a simulator also, but that'll be a completely separate video. Now let's go ahead and try to push this to our PCB. So I'm going to click on Update PCB from Schematic. And now it says there are no errors. It's pulled in the correct footprints that I selected. I click on Update PCB. Now this has happened on my other screen, so it's going to be hard to show, but let me close this out and then I'm going to bring this over. And it actually came in looking like, about like this is what it came in looking like. These are already attached to my mouse. I just have to click somewhere on here, and now I'm able to put these where I want. So by default, my grid is 2.54 by 2.54 millimeter, or a 100 mil pitch, which is great because that's exactly what breadboards are on. So a lot of hobbyists will find this very handy. So I'm going to just move this component off to the side for now. And I want to set my headers up to be the appropriate pitch for a PCB. So this, let's see, we're going to go ahead and put this guy somewhere, there we go, on the grid. I want to be on the grid there, and come on. There we go. So now these two are in the exact same place. If I move it over one, that is a 100 mil difference. There's 200, 300. This is the size of a PDIP device. So if you want to be able to plug a PDIP device in there and solder it, this is one way to do it. Of course, I'm sure they have PDIP footprints already made so that you could just plug parts into those and solder them. This would work for connecting to a breadboard because they also have 300 mil pitch. But this device up here is not going to fit in between here. I can't put it on there. It's going to interact with that. So I'm going to go ahead and move this over a bit more. I'm going to move it over 2 more notches, and then let's see what it looks like. I'm still not used to how to select everything in here, but you can see this guy should fit in here. I'm planning to put it right in the middle, but my grid is too big. So let's look at how we change our grid. I'm going to go up to View and select Grid Properties. In here, you can set 2 quick grid settings. So I have one set to 0.1 inch, or 100 mil, or 2.54 millimeter, however you want to refer to it. And I have the other set to half of that. Now, I'd like to make it a little bit more precise than that. I'm going to go ahead and make that 0.635. Hit OK. So now, if I press Alt and 2 at the same time, my grid becomes that smaller grid. And now I can move this device to be nicely centered in here. And I think we'll be able to fit this in without any problems. So the next thing we need to worry about is the wiring for our board. So I want to run a trace from this pad up to this pad up here. And you can see these light lines. Those are showing where the electrical connections are from my schematic and what I need to connect where. So whenever I first opened this, I went to Place because that's where a lot of board editors put the routing tool, and I didn't see it in there. But then I saw the next menu over is Route. So this is where you need to go. Go to Route, and we're going to route a single track. I'm going to leave it as the default size and just route it straight across. And really, that's all there is to it. Then we're going to route the second one, come out a little bit, and we'll just come around each one of these. Again, I apologize if I don't do this perfectly. My goal is just to show you quickly how you can do this, not necessarily the best practices for board design. That's pretty bad. I don't like that at all. You can actually hit escape to get out of that. Let's zoom in on this, and you can see that that is not where I want it to be. I can't drag it around like I can in Altium. And try this one. Nope, can't drag that either. If I select it and drag it, that works. So what I can do is just move that up a little bit. Now on the other side, I'm going to go to the routing tool again, and that we can press X to do route single track. So I'm probably going to use that in the future. We'll select that bottom pad, run straight down to this bottom through hole, and we will keep doing this. Oop. There we go. I don't think that's quite perfect, but it's definitely good enough for government work. So let's go ahead and turn this into a board. So basically the last thing you're going to have to do once you have, what the heck? That's very strange. Why is this? I don't know why J1 is here, but J2 is not there. That is very odd. So I would expect J2 to have shown up right here. For some reason it's not. And I've done this a couple times, so I know that's always going to show up in my way because I want to put the board right around the edges here. So let's do it anyways and see what happens. In order to build the board outline, I want to go to a different layer. So this is your layer selector in here. That I was working on the top layer, and that's F for front. And then B is the back, so you have front and back of the board. And then I'm going to go on down to edge cuts. So, and this is where I'm going to make a line. So I'm just going to go in and draw a line. Oops, click once to start your line, click once to end your line. And yep, you can hit escape if you want to finish, or you can keep clicking to make a box. So, and I just left clicked at the end, and that tied the box together. So now I can double check that everything is the way I want it by going into View and choosing the 3D Viewer. That pops up this window, and you can see that I've got J1, and for some reason my J2 identifier is not showing up. Okay, so we're going to, now that we have everything placed, we have the board edge in, I want to run a design rules check to make sure I didn't miss anything. That's going to be under the Inspect menu, Design Rules Checker. Here we can see it's not going to do anything until I click on Run DRC. Now, reference J2 is a problem. So where is J2? You can see that J2 accidentally got moved inside of this pad right here. I don't know how I did it, but now I can put it where it's supposed to go. And there we go. That should finish my board design. I'm going to go back, double check with my design rules checker. Run DRC, done, no errors, no issues. This is exactly what I want. So now finally we have our board, and we can take a look at it again just to double check, make sure everything's pretty in the way we want it. It looks, oops. It looks exactly the way I would expect. Nothing on the back because I didn't put anything on the back. This could be done with a single layer board essentially, but I'm probably going to mount the headers the other way around, but I want the silk screen on the top. So when I ordered this, it would be a blank board. So now let's see exactly how you can generate the Gerbers to order this. So I'm going to go ahead and click Save to save my board, and then I'm going to go to File and Plot. And that plot, different from print, it's going to make your Gerbers for you. You can make sure that you have the correct layers checked. So we have the front and back copper, and we have front and back paste, front and back silkscreen, front and back mass, and then we have the edge cuts, that's the board outline. And I'm going to, before I do anything else, I'm going to go ahead and click on Generate Drill Files because I'd like to also have my drill files. So we're going to do in Simple Board, I'm going to make a new folder, and I'm going to call this Outputs. Select that, hit Yes, and Generate Drill File. Close that, then plot all of my Gerbers, and close that. Now let's go to a website and see if it can read what I've got. I happen to already load JLC-PCB. Inside my documents, I have a KiCad projects folder. I believe that's the default folder that it's going to send everything to. And then I'm going to go into Tutorial and Simple Board. In here, I've got my outputs, and you can see everything's here that I wanted. Right click on that, and I'm going to send it to a zip file. You don't have to use 7-zip, but just need to zip these up. And then I'm going to take those and drag and drop them into the Gerber file upload for JLC-PCB. And you can see almost immediately if these are going to be done correctly. Yep, looks like it measured everything that I expected. The board is going to be $2 for 5 copies, and $4 for shipping should be set. So I hope this helped you out with getting at least started in KiCad. I look forward to learning more about this software and being able to share it with you. If you have any specific questions or specific topics you want me to look into, please post them down in the comments. Thanks for watching.